Alright, in the next one, I've already got the stuff with an exponent completely by itself. So I'm going to take the log of both sides. So then I would get log base 3 of 27 to the 2x is equal to just x plus 2. Alright. Again, that x looks a little bit more complicated than the one on the right, so I took the log of that side. And also, this base is a little bit easier to handle. And honestly, I know that 3 to the power of something is equal to 27. Alright, that's the other reason I did that. Alright, so the math magic about logarithms is that exponents are going to come to the front. So then I'm going to have that 2x times log base 3 of 27 is equal to x plus 2. Alright. And then we can solve. And I'm like, okay, like I said, 3 to the something is 27. That would be 3 to the third is 27. So really all I've got is 2x times 3 is equal to x plus 2. Alright, and then I'm just going to have that 6x sitting there is equal to x plus 2. And then I'm going to have 5x is equal to 2, subtracting that x over. So then x is equal to 2/5. Cool beans. Alright, on the next one, again, I've got this log base 10, if you guys don't remember that, of x plus 1 is equal to 5. So again, I need the stuff with the logarithm completely by itself first, which we don't have, so I need to divide off that 2 first. So then I'm going to have log of x plus 1 is equal to 5/2 or 2.5. Honestly, as long as it's a pretty decimal, I don't care, and since I'm going to be plugging that in, I would rather just plug in a pretty decimal if I can. So changing this now to an exponential, I'm going to have 10 to the 2.5 is equal to that x plus 1. Alright, and then I can say, okay, I can type that into a calculator. That's like 316.27 blah 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 equals x plus 1. So then I'm going to subtract 1 from both sides, so I should end up with 315.2278. Alright, so x should be equal to approximately 315.2278. Alright, on G, I've got 2 to the 3x minus 4 equals 5. So I got the stuff with the exponent completely by itself, which means that we're ready to take a logarithm. So then I'm going to have log base 2 of 5 is equal to 3x minus 4. Alright, I can take the change of base formula, so I've got log of 5 over log of 2 is equal to that 3x minus 4, which is going to give me a nasty decimal, to be honest, which is approximately 2.3219 ... is equal to that 3x minus 4. Adding 4 to both sides, I should get 6.3219 yada 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 is equal to 3x. And then divide both sides by 3, I should get x is equal to 2.1073. Please do not round until the end. Alright, so I've got log of x to the third over 6 is equal to 9 minus the log of 2.4. Alright, so again, I've got logarithms on both sides, so there's a couple of different ways to solve this, to be completely honest. The first thing I notice is that log of 2.4 should just be a number, so I can type that in and take 9 minus that number, which will give me approximately 8.619788 yada 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 is equal to that log of x to the third over 6. Okay, cool. And then I notice, okay, well, I can probably separate these a little bit. And you're probably like, but Miss Schuessler, you told us if we have multiple logs, we're going to put it together on D. Well, yeah, but on D, we had 2 different x's in my logarithms, which is why I wanted to combine them. But I notice if I separate these two, I'm going to end up with log of x to the third minus log of 6 is equal to 8.619 blah 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 blah. And log base 6 is also just a number, so I can add that log base 6 to the other side. So I've got log now of x to the third is equal to now 9.39794. Alright. And then I can use exponent rule, the power rule, and whatnot to say, okay, the 3 goes out in front. I've got log of x now is equal to that long nasty decimal or big long nasty decimal. And then I divide both sides by 3. I should get log of x is equal to that 3.1326. Yada 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 yada. I still need to figure out what the heck x is, but now that I've got my log by itself, I can change this into being an exponential. Alright, so now I can go ahead and say, okay, well, my base is 10. So I've got 10 to the nasty freaking decimal, but hopefully we've stored that in our calculators, is equal to x. And we type that in, and we get this lovely number of x is equal to 1,357.2088. Alright. On I, which is the penultimate question, we need to get the stuff with the exponent completely by itself. So I notice I've got 1,000 times e on I. So I'm going to divide off that 1,000 because it's got nothing to do with the stuff with the exponent. So I can get rid of it. So I should just get 1.5 is equal to e to the 0.04t. Alright. And then I've got an e, which means that to get rid of e, I need to use the natural log, which is represented by ln. So I'm going to take the natural log of both sides. So I'd get ln of 1.5 is equal to 0.4t, because again, sorry, I misspoke, 0.04t. I'm really bad about bringing down 0 sometimes. Okay. So, again, e's and ln's undo each other. They're inverses of each other, so they just kind of go away because it's 1. Alright, and then the exponent would have came out in front of that ln, leaving me with just the exponent. Okay, so divide both sides by 0.04, and we're done. So then you would have t is equal to 10.1366. Alright, and then we've only got a couple steps on j, but we can do it. So I'm going to divide both sides by 5 first to try to get that ln completely by itself so I can figure out what the heck x is. So I should get ln of x, or natural log of x, is equal to 4. So now I can change this into an exponential. Again, since I've got ln, that means that my base was e to the 4th is equal to x. And I type that in, and I should get x is equal to 54.592. Other than that, I hope you guys have a great rest of your day. Like I said, if you got questions, don't be afraid to ask me. I'm here a lot. So I'm here to help. I will see you guys later. I hope you have a great rest of your day.